Hello everyone, welcome to the video tutorial series of the wireless communication. I'm your instructor Varshata. Let's start our today's lecture series. So at the end of this video, you will be able to learn about the different types of improvement techniques that is available in the wireless communication. So let's start our lecture series. So before learning about the improvement techniques, let's learn some basics. So have you ever wondered what would happen if the wireless services are increased? Okay, so now in current era we are knowing that we are using the wireless technology more and more. Okay, so if we are using the wireless technology more and more, the services should be improved more and more. Okay, so for that, if the services are increased, if this increase, so how we can define such, how we can define the services, how we can provide the services to each and every user without any interference. Okay, so there are lots of confusions are there in the wireless communication system. So let's learn about this, which type of techniques that we can use for this purpose. Okay, so what is the improvement technique? So let's learn. So as the demand for the wireless service increases, the number of the channel assigned to the cell eventually become insufficient to support the required number of the user. Because in current era, most of all the users are using the mobile phones, they are using the wireless devices. So the services to that particular devices should be provided. Okay, so as the demand of this wireless services increase, so the channels that is available, that is in the less number of the channel. So we cannot assign each and every channel for the particular device. So for that we have to improve the such techniques. Okay, so at this point cellular design techniques are needed to provide more channel per unit coverage area. So per cell cluster, now all of you will about what is the cell cluster. Okay, so per cell we are using the hexagonal cell. So per cell we require more and more channel to define to provide such services. So techniques that is such as cell splitting, sectoring, and the coverage zone approach, we can say the micro cell zone concept that is used in practice to expand the capacity of the cellular system. So this three technology that we are using to enhance the wireless technology services to provide more and more services to the more and more users. Now, cell splitting allows an orderly growth of the cellular system. Okay, cell splitting, that means you are splitting the cells. So cell splitting allows the orderly growth of the cellular system. Then sectoring. Sectoring uses the directional antenna to further control the interference and the frequency reuse channels. And the zone microcell concept that distributes the coverage of the cell and extends the cell boundary that is hard to reach the places. At the places that where we cannot reach, so at that time we can use this microcell zone concept, this technique to reach at that particular places. So while cell splitting increase the number of base station in order to increase the capacity, sectoring and zone microcell rely on the base station antenna placement to improve the capacity by reducing the co-channel interference. Now all of you are aware about what is the co-channel interference and what is the adjacent cell interference. So to reduce the co-channel interference, this two technique is used, that is the sectoring and the zone microcell concept. Now let's start with this technology. So first technology is what? Cell splitting. Okay, so here in this figure you can see, this figure defines the cell splitting. Here you can see this is what? The hexagonal cell cluster. Okay, here the cell cluster is given to you, and here in the middle of this you can see with respect to A, we have divided the cell in different small cells. That means we are splitting the cells. So when you are splitting the cells, here you can see in the sky color figure. So here you can see how this cell is defined. Okay, so newer cells you are generating by splitting the cells. You can split this channel by reducing its radius. Now here you can see this is the total how all the cells are divided. So like this way all the cells are divided in the smaller cells, so that we can say it is the cell splitting. So now let's learn about the cell splitting. So cell splitting is the process of subdividing congested cell into smaller cells. Okay, we are dividing this entire cell into smaller cells, each with its own base station and the corresponding reduction in antenna height and the transmitter power. Okay, so here this basic is there what? We are dividing the cell in the small cell. So we don't require the with a high height antenna. Okay, the smaller height antenna is also will be used in this small sectoring, small splitting cells. Why? Because the area that is covered by that particular cell is less, so we require the less transmission power. Okay, and you can reduce the antenna height. Cell splitting increase the capacity of the cellular system since it increase the numbers of the times that channels are reused. So by defining the new cell which have a smaller radius than the original cell, by installing the smaller cells, that is called the microcells, between the existing cell, the capacity increase due to the additional number of channel per unit this area. So what is the exact concept of the cell splitting? We are increasing the channel to service more and more users. Okay, so we are dividing that entire entire hexagonal cell in the small cell, and we are defining the newer channel for this micro cell also. So total number of channel will be increased in that particular cell area. Now let's learn about the formula for the original cell. The transmission power, that is PR0, PRO, or we can say PR0. So that is the original cell power that we can calculate using the PT1, that is R raised to minus PT1 into R raised to minus 1. So total power that we require to send the data in that particular cell area, and R raised to minus 1. Okay, so here N is what? The path loss exponent. And R is what? The radius of that particular cell, that is the original cell. Now if we are generating the newer cell, that is by splitting the original cell, so the formula will become PRN, that is for the newer cell transmission power, that is PT2 into R by 2 raised to minus N. Okay, so here the transmission power that is required in the newer cell, and the radius divided by 2, because we are dividing the we are decreasing the radius also. Why? Because we are splitting the cell, so radius will also be decreased, and raised to minus N, that means what? N is equal to path loss exponent. That means whenever you are transmitting the power will be maybe reduced, or maybe interferences are there. So whatever the exit power you are transmitting, you will not receive the same signal at the same speed, etc. So that's why minus N path loss exponent is there. Now if we are considering the 4 cell reuse concept, okay, and we are using this formula, so what power will be required in the newer cell compared to the original cell? So PT2 is equal to PT1 divided by 16 that we required the power in the newer cell. So here you can, from this formula you can see that we required the less number of power in the that splitting cell than compared to the original cell. Why this 16 is there? But when you are putting the value, that is in this formula, so R divided by 2, R divided by 2, that means we are defining the radius, we are decreasing the radius, and here you can see path loss exponent, the end cellular concept is what? It is equal to 4. Okay, so when you are putting this, so 2 raised to 4, that means what? This 16. Okay, so path loss exponent, if you will put the value, that is 16. So you will get the answer, that is PT2 is equal to PT1 divided by 16. Now what are the advantages of this cell splitting? So greater system capacity is there, okay, because we are dividing the cell, we are splitting the cell, so numbers of channels are available, more numbers of channels are available, so we can give the services to the more users. Then reuse of cell is there, then transmit power is reduced. Then what are the disadvantages of the cell splitting? So more tower required, because we are splitting the cell, and in each and every cell we require one base station. Then more number of handoff is required, because we are splitting the cell, so handoff is also increased. So these are the advantage and disadvantage of this cell splitting. Now let's learn about the cell sectoring. Okay, so cell splitting achieves the capacity improvement by essentially rescaling the system. You are rescaling the system, so by that you will achieve the capacity improvement. Now by decreasing the cell radius R and keeping the co-channel reuse ratio, that is D by R, unchanged, cell splitting increase the number of channel per unit area. Okay, we are keeping the co-channel reuse ratio D by R, that is constant. We are not changing the cell. Okay, we are just dividing the cell, So however, another way to increase the capacity is to keep the cell radius unchanged and the SIC method to decrease the D by R ratio. Okay, so here what will happen? We are defining the radius as a constant. We are not changing the radius, but we are decreasing the D by R ratio. That means we are decreasing the co-channel interference ratio. So in this approach, capacity improvement is achieved by reducing the number of cells in the cluster and thus the increasing the frequency reuse. So however, in order to do this, it is the necessary to reduce the relative interference without decreasing the transmitting power. Okay, so in order to do this, what will happen? It is necessary to reduce the relative interference without decreasing the transmitter power. That means we are not decreasing the transmitter power. Transmitter power is there, radius is there, and still we achieve the more capability. So the co-channel interference in the cellular system may be decreased by replacing a single omnidirectional antenna at the base station by several directional antenna, each radiating within the specified sector. Okay, so we have to replace the omnidirectional, we have to replacing a single omnidirectional antenna at the base station by the several directional antenna. So by using the directional antenna, a given cell will receive the interference and the transmit with only a fraction of the available co-channel. So the technique for decreasing the co-channel interference and the increasing the capacity by using the directional antenna, that is known as the cell sectoring. So what is the difference between cell splitting and cell sectoring? In cell splitting, we are decreasing the radius. Here we are not decreasing the radius. So here and transmit power is also decreased in the cell splitting. Here the transmit power is same, but the antenna is replaced by the directional antenna. The factor by which the co-channel interference is reduced, that depends on the amount of the sectoring used. Okay, which type of sectoring we are using, that depends on the factor of the co-channel interference. It depends on it. So a cell is normally partitioned into 120 sector, 120 degree sector or the 60 degree sector. So let's learn about this so you will have the better idea about this. So now here you can see the different sectors are there. So at the 360 degree, at 120 degree and at 60 degree. Okay, so here the 360 degree, that means we are not sectoring the cell. At 120 degree, if we are considering, we are sectoring the cell at so 3 subcell is there. And if we are sectoring the cell at the 60 degree, we have 6 subcell. Now, how to calculate the co-channel for each and every cell if we are using the sectoring. So if we are doing at the 360 degree sectoring, so here consider this, the middle of the red color cell that is sectored at the 360 degree. That means we are not dividing it in particular sectors, that is the same. So here the number of co-channel cell is 6. How this number of co-channel is 6? So here consider this red color cell and this around cell, that edge is connected to this particular red color cell. So 6 edges are attached to different 6 cells. So that's why the number of co-channel cell is 6 in this 360 degree. Now, how to calculate the co-channel cell for the 120 degree? So here consider that middle of the cell, that is the white color cell, and we have divided that cell at the 120 degree. So as I told you, if you are dividing the 120 at the 120 degree, so you will get the 3 subcell. So now consider the first subcell from that white color cell. So here you can see, if we are considering this first cell this side, so yellow color cell and this green color cell is attached to that particular cell. Okay, and if you are considering the cell at the upside, so that light green color and the orange color cell is attached to that particular cell. That means its edges are connected. Same way, if you are considering this cell that is downside in the white, so it will attach to this skin color cell and the yellow color cell. So what is that? The each and every cell, its edges is connected to the 2 different cells. So that is what the number of co-channel factor is 2 here. Got it? So number of co-channel cell is 2. Now same way, how to calculate the co-channel cell at the 60 degree. So if you are sectoring at the 60 degree, that means here you can see the white color cell is divided in the 60 degree sectoring. So if you are doing the 60 degree sectoring, you have the 6 cells in 6 subcells. Now we are considering the for each and every cell subcell in that white color cell. So you can see each and every cell is connected to one cell only. The edges is connected to one cell only. So number of co-channel cell is 1. Now what are the advantages and disadvantages of the cell sectoring? Okay, so advantages, it improves the SI ratio, that is signal to interference ratio. It reduces the interference and increase capacity. Okay, so as you can see that if you are dividing the cell with the 60 degree, we just have the one co-channel interference. One co-channel cell is there. Okay, it reduces the cluster size also. Okay, and what are the disadvantage of the cell sectoring? So it reduces the coverage area and it increases the number of antenna. Now what is the difference between cell splitting and cell sectoring? So let's learn. So to reduce the transmit power, cell is subdivided in the cell splitting. Okay, so cell splitting, we are dividing the cell, we required the less height antenna and transmit power is also reduced. And in cell sectoring, for decreasing the co-channel interference, okay, so for decreasing the co-channel interference, cell sectoring is used. Here radius is decreased and d by r is constant. Whereas in cell sectoring, radius is constant, as you know that radius is constant and d by r is decreased. That means co-channel interference is decreased here. Here the cell splitting, that means subdivision, and cell sectoring, that means the sectoring. We are sectoring it, and cell splitting, that means we are dividing the cell. SI maintains by affecting the transmit power, and here signal to interference ratio maintained by using the directional antenna. Okay, so these two techniques will be used. Then handoff is less compared to the cell sectoring, and here more handoffs are there in the cell sectoring. Sorry. Now next is the micro cell zone concept. This is the third technique that is used. So micro cell zone concept. The problem associated with the sectoring technique is increase in the numbers of the handoff. So this put an additional load to the switching and the control link elements of the mobile station. Because we are doing the sectoring, we are, as you know that the 60 degree sectoring, we have 6 subcells are there. So if 6 subcells are there, so area that is covered by that particular sector, that is very less compared to the entire cell. So if the device will move in that particular cell area also, so handoff is required. Because we have the different antenna for each and every cell, that's why. So solution to this problem is based on the micro cell concept. So in this scheme, all the 3 or more zone sites represented as the Tx by Rx, that is are connected to the among band swaps. So this is the ratio. Let's see in the figure. So here you can see this 7 cell cluster is there. So here the zone 1, zone 2 and zone 3 is there. Now here at the each and every edges, the Tx by Rx, that means the antenna is defined over that. And here for the zone selector sector, this will be covered, this entire cell will be covered, connected with the microwave or coaxial cable or the microwave links. Okay, so we are defining the micro cell of that particular cell, that is defined using the zone 1, zone 2 and zone 3. Numbers of micro cells are there. And each and every cell that have own base station, so that is defined at the edges of the micro cell, and it is connected to the zone selector. So zone selector will select where to transfer that particular data, and this zone selector will be connected to the base station. So signals will be received from the base station and transmit to the base station. So let's learn what is the micro cell zone concept. So the transmission media used for the connecting the zones to the base station, that is the coaxial cable, fiber optic cable or the microwave links are there. So each cell consists of the base station and the multiple zones. A mobile traveling within the cell is served by the zone that has the strongest signals of all the zones. Okay, so here whatever the zone have the strongest signal, so that will that provide the signal to that particular mobile station. Okay, so as shown in the figure that we have seen in the last slide, the antenna in zone are placed at the outer edge of this cell. So, and any base station channel can be assigned to any zone by the base station. Okay, so any base station will be assigned to the any zone. So this proves that it will be better approach than the sectoring. So as a mobile will travel from one zone to the other within the cell, it use the same channel. No channel will be changed. Okay, so same channel will be used in that particular cell when they are traveling from the one zone to another zone. So this will avoid the handoff. We don't require the handoff because we are not dividing the cell. So just different zones are used. In that particular zone, we are using the same channel. Okay, so this will avoid the handoff, which another advantage of the sectoring approach. Now, thus it is thus a given channel is being used only in the particular zone in which the mobile is traveling. So the base station radiates its power in the localized manner. Okay, only in localized manner the power will be transmitted. So this will reduce the interference. Okay, we are not sectoring the cell, so no interference is there. So this will reduce interference. The channels are distributed in a time and space by all the zones and are also reused in the co-channel cells. So the microcells concept is very useful along with highways or in the busy urban areas. Now, what are the advantages and disadvantages of the microcell concept? So it improved the signal quality. Then a number of handoff is reduced because we are not splitting the cell, we are not sectoring the cell. So number of handoff is reduced because the same cell concept we are using. We are just dividing in the different zones, and for the different zones, the particular base station is there, but we are using the same channel for in all these zones. Low power transmitter is used. Co-channel interference is also reduced. Now, what are the disadvantages of the microcell zone concept? More antennas are required. Why? Because we are dividing the in zone. So for that particular zone, we are requiring the more antenna, but we are using the same frequency channel. Base station need to be more sophisticated to handle the transfer of call from one zone to another zone within the cell. So when the mobile station will move from one zone to another zone, that will be responsibility of the base station to maintain this quality of the signal and without the interference. So in this video, we have learned about the improvement techniques. So we have learned about the three types of different improvement techniques, that is cell splitting, then cell sectoring, and then microcell zone concept. Each and every techniques have their each advantages and the disadvantages. So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture with a new topic. Thank you.